Okay, we're here with our student Rita, and we're talking about compound event probability. Ready to go, Rita?
Yep.
Okay, so first let's just think about what probability is. When we think about the number of things that can happen, we call that the sample space, and it can have a whole bunch of different possibilities in it. Each one of these little dots is a possibility. Do you understand that?
Yeah.
Okay, so then the thing is that there's a probability that certain of those things will happen, like let's say those two things. And when we think about the possibility or the probability of an event, what we do is we think about the probability as the number of times the event occurs in the sample space. In this case, it would be these two things, divided by the total number of possible events in the sample space. So everything. And that's what probability is. It's just how likely it is to happen. And sometimes we write it in just a little bit of a different way. We put P instead of writing out probability. And instead of saying of an event, we put in parentheses the name of that event. In this case, we just put A as a placeholder. But it's the same thing. Number of times the event occurs in the sample space divided by the total number of possible events in the sample space. Okay? Okay, so that might not make complete sense to you, but let's give it a couple of an example here. We'll start with a single event example. So eventually we're going to get to a compound event. That's when more than one thing happens. Like a compound word is kind of like two words put together. But this is just going to be a single event. And this event is a number cube rolls an even number. Okay, so first of all, if you're going to roll a number cube or a die one time, how many possibilities do you have?
6.
6 possibilities, right? And then how many even numbers are there in there?
3.
3. Okay, so let me show you how we would write that then. We would say the probability P of an even number, that's that A, we just put the thing right in here so we know what we're talking about. And it could happen 3 times out of a total of 6. So there's 3 ways that you can get an even number, and there's 6 total possibilities. So then that's how we set up this probability fraction here. Now 3 6, that simplifies to 1/2, which is 50%, right? So the probability that you'll get an even number is 50%. Okay,
Right.
make sense?
Yep.
Okay, now if I said to you, what would be if you rolled a number cube 700 times, how many times do you think that you would get an even number, roughly? Well, you just take this 50% or convert it to a fraction like 0.5, and you multiply it by that number of times I said, 700 times, and you would say, well, about 350 times I would expect to get an even number. Does that make sense to you?
Yeah.
Okay, so the thing is that you're probably not going to get it exactly 350 times. So probability is about estimating how many times it will happen. When you do actual things in the real world, sometimes they don't actually happen to that exact number.
Okay.
Okay, that's single event. Now let's talk about a compound event. And this one will be, you're going to make 3 coin tosses, okay, and each time it could be heads or tails. And the question is, how many times do you think you'll get one tail total? Okay, so you could, get heads the first time, heads the second time, and tails the third time. That would count because there was only one tail in there. Okay. But if you did tails the first time and then heads and then tails, that wouldn't count because that would be 2 tails. Okay.
Okay.
So what I was just doing is I was starting to name the different possibilities that are there so we can get the total number of possible events in the sample space. You know what? It's really hard just to talk it out. The best thing to do is to make some sort of chart when you're doing this, okay? So let's go ahead and make a chart. I've done it here. And what I've done is I've said, okay, the first time I toss that coin, it can be heads or tails. Then there's the second time. If I get heads the first time, the second one could be heads or it could be tails. If I get tails the first time, the second one could be heads or tails. And then I'm going to toss it a third time. And then each time it can be heads or tails all the way down. Now, what that means is that one possibility that you can trace the lines to get each possible event. One possibility is you get heads, heads, heads. This one right here, H, H, H. Does that make sense?
Yes.
Okay, another possibility is heads, heads, tails. And all the way down to get to tails, tails, tails. Okay? So this is all right here. This right here. That's the total number of possible events in the sample space. So let's count those up. How many are there? 1, 2, 3, 4, 5, 6, 7. Looks like there's 8 total possible events, right?
Yeah.
Okay. So that means that the denominator of our fraction is going to be what number?
8.
8. Okay? Now the numerator is the number of times that the event we're looking for occurs. And that's that there's only one tail, or exactly one tail. So let's figure out how many of those there are. Okay, there's one right there. Heads, heads, tails. And then there's one right there. Heads, tails, heads. And there's one right there. Tails, heads, heads. Are there any others where there's just one tail?
No.
Okay. So how many were there?
Let's see. Was it 3?
1, 2, 3, I think. Okay?
Yeah, 3.
All right. So now let's go ahead and write our probability here. P, probability of one tail, is there were 3 possibilities out of 8 total. Okay? There's the 3 times there were just one tail out of 8 total possibilities. Does that make sense up to this point here?
Yes.
Okay? Then you can use a calculator. You can do this math by hand too, but you can use a calculator to get to 0.1275, and then you can convert that to a percentage. So the probability, if you flip a coin 3 times, that you'll only get one tail is 12.75%. Does that make sense?
Yeah.
Okay? So the critical thing here was to make that table or some sort of chart. Write it out. Draw pictures. That's critical to really understand math. Now, if I asked you, okay, then if you did this 3-coin flip once, and then you do it again, and you do it again, you do it 1,000 times total, how many times do you think you would get just one tail? Well, we could just use that multiplication again. We could take the 0.1275, multiply it by those 1,000 times that you would do it 3 times, and then we would probably round here, because that would get 1,000 times this is 127.5. We'd round it up to 128 and say, I would expect to get just one tail 128 of those 1,000 times. Does that make sense?
Yeah.
Okay. And then let's just do one other example here so you can see a different way of making a chart. We won't actually do a problem here. But here's another compound event example. It's 2 rolls of a number cube. Okay, so we're going to roll it once, and then we're going to roll it again. And we could ask ourselves all sorts of questions. We could ask ourselves, how many times do you get an even number and an even number? Or an even number and an odd number? Or how many times is the total greater than 10? You know, there's any number of questions that you could ask of that. The key is to go ahead and make some sort of chart like this. And there's a number of different ways you could do it. But one way that I've done it here is to say, okay, there's a first roll here, and it can be 1, 2, 3, 4, 5, or 6. And there's a second roll here, and that could be 1, 2, 3, 4, 5, or 6. And then in the middle here, I've just put what the 2 rolls are. This one, you got a 1, and then you got a 1. Here, you got a 1, and you got a 2. So here's all the possibilities in the what? What do we call this?
The sample space?
The sample space. This is all of them. How many possibilities are in this sample space?
Let's see. 6 times 6, 36.
36 different possibilities if you roll a number cube twice. So that's going to be your denominator no matter what. And then whenever you get asked a question like, how many times do you get doubles? You know, you can figure out how many times there are doubles in here and divide that by 36. If it says how many times do you get an even total, you could count up all the different squares here where there's an even total and divide that by 36. It's all about this idea of the number of times the event you're looking for occurs in the sample space divided by the total number of possible events in the sample space. And that's how you handle this tricky thing of compound event probability. Make sense?
Yeah.
Great job.